Hello everyone, welcome back. Let's talk about another medium problem on Leetcode today. Longest subarray with maximum bitwise AND. Leetcode 2419. In this problem, we are given an integer array nums of size n, and we should return the length of longest subarray such that value of the subarray is also maximum possible bitwise AND result. A subarray is a contiguous sequence of elements within an array. Then in example 1, for the given array, the maximum bitwise AND of a subarray is 3 and the longest subarray that has the value is 3, 3. So the subarray length is 2, hence we return 2 as our answer. Now in terms of solution, the naive way to solve this problem will be to run two nested loops. The outer loop will track the start of the subarray and the inner loop will track the end of the subarray. And once we generate those subarrays, we will just do the bitwise AND between the values of that subarray and track the maximum value. And whenever we find the maximum value, we also keep track of the maximum length of the subarray. And at the end, that will be our answer. But running two nested loops takes O of n square time. And now the question is, how can we do better? And for that, let's look at the bitwise AND operation a bit closely. The bitwise AND operation outputs a 1 only if all the corresponding bits of its operands are 1. Otherwise, if any bit is 0, the result for that bit is also 0. So this operation tends to reduce the number of ones in the result compared to the operands and increase number of zeros. So let's look at some examples for that. So suppose we have to do 1 and 3, and binary representation of 1 is 0, 0, 0, 1, and binary representation of 3 will be 0, 0, 1, 1. And now if we do bitwise AND between them, only this bit in both the operands actually retain. So we will get output as 0, 0, 0, 1, which is equal to 1. But instead, now let's do bitwise AND between 2 and 3. Binary representation of 2 will be 0, 0, 1, 0. And binary representation of 3 was 0, 0, 1, 1. So again, this time only this bit is retained, but this bit in 3 becomes 0. So we will get output as 2. And finally, let's look at bitwise AND between 3 and 4. Binary representation of 3 is 0, 0, 1, 1. And binary representation of 4 is 0, 1, 0, 0. So this time we will get 0 as an output. So the key observation here is that the result tends to have fewer ones, essentially introducing more zeros, or at maximum equal ones compared to the input operands. So the bitwise AND operation is particularly different from other operations like sum or XOR in that adding more elements usually decreases the value. So what we mean is A and B is less than equal to A for any value of A and B. So at maximum it can be equal, but it tends to go down in general, right? And now let's get into the problem and see how these properties can help us solve it. So the maximum bitwise AND of any subarray is likely to be one of the elements themselves, as adding more elements will generally introduce more zeros into the bitwise AND, reducing its value. So we need to identify the maximum bitwise AND value k first, which will be the maximum number in the array. Then we know that if we do A and A, we will get A, because internally with the same binary representation, wherever the set bits are there, when we do the AND operation, we will get the value 1 there, resulting in the same number. So then we find the longest contiguous subarray where all the elements are equal to this maximum value, because this ensures that max bitwise AND value is maintained and we get longer array as well. So then our problem boils down to finding the longest consecutive subarray with maximum value in the array. So it's a two-part solution. First, we find out the maximum value in the array, and then we find the longest contiguous subarray where each element is equal to the maximum value. So now let's jump into the code part. So first, let's find the max value in the array. We can define max val for that. And now we can just loop on the array. And if number is more than the current max value, we will set max value equal to num. We can set the max value using math.max function and finding out the maximum value between the current maximum value and the current number, but up to you. Then we will define our answer, that is maximum length of the contiguous subarray with all elements equal to the maximum value. Let's also take current length to store the current sequence length of all the elements with the maximum value. Now we can loop on the numbers array again, and if number is equal to max value, that means we will just increase our current length by 1 and see if it updates our maximum length value. So our max length will be maximum of current maximum length and current length. But if the number is not equal to maximum value, then we should reset the current length to 0 so that we can use it to track next sequence of maximum values. And that's it. And finally, we return max length as our answer. Now let's run this code. Cool. Let's submit this code. Awesome. In terms of time complexity, it will be O of n, where n is the number of elements in the nums array. And the reason is when we do the first pass to find the maximum value, that takes O of n. And then in the second pass, we again run the loop on the nums array, and that again takes O of n. And in terms of space complexity, it will be O of 1 because we are not using any extra space other than few variables here and there. So that's it for today. I hope this video was useful for you. If it was, please like, share, and subscribe. Press the bell button for the notification. The code link is in the description below. If you have any questions or suggestions, please write them in the comment box. Thank you for watching. See you next time.